Hey guys, how you doing today? All right, so we're going to talk about how many solutions there are to a system of equations. So much fun. All right, so remember we were talking before. Basically, wherever lines will cross, that's going to be the actual solution. Now, in our question here, I'm asking how many solutions there are, not what is the solution. Okay. So as soon as you know enough information to determine how many solutions there's going to be, that's all you really need to do. All right. So let's begin with no solution here. So if I said the solution is where the two lines will cross, if the answer is no solution, that means they're never going to cross. Now the only thing we know about this right now is that lines that are parallel never cross. So no solution, all right, our lines never intersect. Okay, an example of that is going to be parallel lines. It's pretty much the only thing we're going to run into these days. Okay, we could run into it with other types of lines like quadratics. We'll talk about that in a second. Let's just graph an example here. So if I were to give you, let's change up some colors. All right, got baby blue here. Baby blue. All right, let's say y equals 2x minus 3. Okay, so that line has a y-intercept of negative 3, 1, 2, 3. My slope is 2 over 1, so I go up 2 over 1, up 2 over 1. I go down 2 over 1 this way. My line is going to look a little something. Wow, that was bad. That was a little bit better there in my second try. All right. Caroline's going to look a little something like that, though. So let's do this green-eyed monster over here. We get y equals 2x plus 4. Man, those look pretty similar. Can you even tell the difference? I don't know. But here, my y-intercept would be 1, 2, 3, 4. My slope is 2, so I would go up 2 over 1. That's kind of off my graph to the right here. I could also go down 2 over 1 this way. Down 2 over 1. Okay, down 2 over 1. Play a fun game called Connect the Dots. Okay. Hopefully you guys can see that those two lines are never ever going to cross. Okay, so the answer would be no solution if this was your problem. Alright. Like I said, I want to do one other one here, just so you get in a sense of that it doesn't have to be two parallel lines. Let me just sketch something real quick. Okay, like a quadratic, if I'd given you a quadratic that looked something like this. Okay. And then something linear, which would be like y equals mx plus b, that looked like this. Okay, hopefully you can tell those two lines are never ever going to intersect, right? This one goes up, and then it goes up really, really fast. It's never be seen again. This is linear. It's going up at a steady rate. Okay, they never actually cross paths, so it's going to be no solution. But these two lines are not parallel to each other. That's just another example. There's lots of them out there, but that's something you might be dealing with this year yet. One solution means our lines are going to intersect in one spot. This is honestly going to be most of the stuff we're going to be dealing with. Most linear equations will only meet in one spot. Okay, so we could just pop up an example here. Y equals 2x minus 3 again. Let's stick with that guy. Okay, let's not do the screen again. Ooh, purple. Purple. La, 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 la. I'm just kidding. I'm not going to draw on the camera. That'd be silly. Y equals 3x minus 5. All right. So we're going to graph these two and see what we got here. So this big blue is going to be a negative 3 for my y-intercept. Okay, my slope here is 2, so I'm going to go up 2 over 1 to the right, up 2 over 1. Down 2 over 1 this way also works. Okay. Then we're going to be left with y equals 3x minus 5. My y-intercept is negative 5 here. Okay, I go up 2 over 1. I'm sorry, up 3 over 1. My bad, I go up 1, 2, 3 over 1. Go up 1, 2, 3 over 1. Yay. That was a little bit off there. Alright. So they intersect actually at 2, comma 1. Okay, so that is the solution. Now understand, I'm not asking you on these problems what is the solution, but here the solution would be 2, comma 1. X is 2, y is 1. So there's only one solution. Okay, they intersect at one spot here. Two solutions. Okay, so this is something that's, well, really you can't have two linear terms. Two linear terms will always be no solution, one solution, or many solutions. Okay, but on the SAT, a lot of times they're going to ask you how many solutions are there, and your options are going to be none, 1, 2, and then many. Okay, so I want to talk to you, when is there ever going to be two solutions? Okay, one of your terms cannot be linear. So let's write that down. One or more. It's not how you spell or. Well, it is, but not the type we were talking about. One or more equations not linear. Okay, so what might this look like? I got a lovely example here for you. Let's do y equals x squared minus 4. Alright, so you guys notice that my degree, my largest exponent, is 2 now. That's not linear. All of these can be written y equals mx plus b, so that means they are linear equations. This is a quadratic equation. My degree is 2. My other equation is going to be, oh, we got y equals x, and then, what is it, minus 3. Nope, minus 2. Alright. So let's go ahead and try to graph these and see what we got going on here. So this one, if you guys maybe remember, it's a quadratic equation. Okay, it's going to be shifted down 4. So I go down 1, 2, 3, 4. That's going to be my vertex. Quadratics, they go over 1, up 1, then over 2, up 4, and then over 3, up 9. So it gets really big really fast. Over 1, up 1, over 1, up 1, over 2, up 4, over 2, up 4, over 3, up 9. That's going to be off of our graph really quickly. Okay, this guy is y equals mx plus b. That one is linear with a y-intercept of negative 2. My slope from there is I go up 1 over 1, up 1 over 1, up 1 over 1, and I could go down 1 over 1 this way. Okay. If you guys see here, they're going to really intersect at two places. This one intersects at 2, comma 0. This guy is at negative 1, comma negative 3. Okay, so this is one solution, that's two solutions. They do in fact cross in two places. Alright. But if you got two straight lines, they're never ever going to cross more than once. Well, many solutions, I guess, but you'll see what happens here. On many solutions, basically lines intersect infinite times. Okay, really what we're talking about here is if they're the same exact line. Alright, so let's go ahead and try to do one of these, huh? Alright. So, we got, y y equals 2x minus 3 again. Okay, that's one of them. The other one is going to be 2x minus y equals 3. All right, so let's go ahead and graph that top one because that's easy to graph. We've graphed it 2 times already. It's this big blue line. Y-intercept's negative 3. My slope is up 2 over 1, up 2 over 1. Okay, so my graph's going to look a little something like that. Now, just looking at this purple line, I don't know how to graph it. Okay, so I need to solve for y. Guys, if you don't know how to graph a line, just solve for y. Make it look like y equals mx plus b, and then you know the y-intercept, you know the slope, and it should be a piece of cake. So I'm going to solve for y, so I get negative y. I subtract 2x is going to equal negative 2x plus 3. At which point I'm just going to divide by a negative 1, leaving me with y equals 2x minus 3. I go to graph this. My y-intercept's negative 3. My slope is 2 over 1. I go up 2 over 1. Whoa! That looks really familiar. Hey, guys, these are the exact same line. Okay, they didn't look the same when I gave it to you because I like to be tricky like that. Okay, but basically they're going to be infinitely many solutions. Okay, so you can just say many solutions, same as infinite solutions. It doesn't really matter. The biggest thing is you understand it's not all solutions. Okay? Every point on this line is a solution. So, like here, we have the point 0, negative 3. We have the point 1, negative 1. 2, comma 1. All of these are going to be solutions going on forever and ever and ever, basically as long as you can carry out this line and make points. Also remember, there could be not nice numbers anywhere on this line. Okay? Really, a line is a set of infinitely many points. Okay, so there's lots and lots of points on here. Each one of those points would be a good answer. Okay, but we can't write all those points down, so that's why we just say many solutions or infinite solutions. Sweet. So hopefully that helps you visually understand if there's one, two, many solutions or no solutions. Okay, well, like I said, guys, I'm not asking you to actually figure out what the solution is. I'm just asking you how many solutions are there. So let's do some practice with all this, huh? Once I've done erasing. Yeah. All right. So here's our problem. How many solutions? So I'll just write one down and we'll talk about it a little bit. All right. So if these were your two equations, I asked you to figure out how many solutions are there. I'm not actually asking you to solve it, okay? I'm asking you how many solutions are there. And you just have to give some kind of reasoning behind this. So if I look at my first one, my slope really is going to come down to slope a lot of the time. My slope is 4. Here, this is point slope form. So I go through the points. Okay, this is my x value, this is going to be my y value, but they're always the opposite. So negative 3 comma negative 3. My slope is going to be negative 1 over 4. Remember, this is like y minus y1 equals m times x minus x1. So the thing I know about slopes is these are opposite reciprocals, which means that this, or I guess these two lines are perpendicular to each other. Perpendicular lines will cross once at 90-degree angles. Okay? So just by knowing that information, I don't have to go through and solve. I can just say one solution. Okay? Because they are perpendicular lines. Now you're really looking if there are basically two things that are linear, y equals mx plus b, this one's point slope form. Okay, you know it's either going to be one solution, no solution, or many solutions. Okay, so just understand that no solution and many solutions are always going to have parallel slopes. Okay, basically you're going to have the same exact slope. If they have the same exact slope, you're going to have to do a little bit more work and figure out if it's going to be no solution or many solutions. Okay? However, if your slopes are anything else, you're always going to have one solution. Okay, so that's really kind of what you're trying to determine here. I'm going to give you guys a couple more problems, see if you can try some on your own. Billy Bob. Billy Bob. Hi, Billy Bob. Okay, there's going to be lots of different ways to figure out the answers to these, so I'll try to walk you through a couple, but I do want you to see if you can figure these out on your own. Okay, we got x equals 3, y equals negative 5, a, b, c, d. Y plus 4 is going to equal 1/2 times x plus 8. And then we'll do x minus 2y equals 10. So we'll just do those three for now. You guys go ahead, give it a whirl, see if you can figure it out. And then when you're ready, come on back. Took you a little while, didn't it, huh? No worries. All right, we got all the time in the world. So let's check this one out. Now, I could look at these. I don't know what my slope is just by looking at them, okay? I could solve for y on both of these and figure out if it's going to be parallel slopes. Or I could just go ahead and start solving, okay? You can use lots of different methods, I said. This one, I'm going to try to solve for x and y. Now, understand when we solve for x and y, if I get an answer for x and y, that means one solution. If my x and y's cancel, it's either going to be no solution or many solutions. So if they cancel and we're left with a true statement, it's going to be many solutions. If they cancel and we're left with a false statement, then it's going to be no solution. So, let's check this out. Hopefully you guys remember how to solve these. I'm going to call this equation A and this one equation B. Remember, these are all stacked on top of each other perfectly. I want to try to add them together to get rid of either my x's or my y's. Right now, if I add them, my x's are going to give me negative 2x. My y's give me 3y. I don't want either one of those. I recognize if I multiply equation A by 2, that gives me 4x, which will cancel with a negative 4x. Okay, so I see that, so I'm going to multiply equation A by 2. I'm going to multiply each one of these terms by 2 though. So 2 times 2x is 4x. 2 times negative 3y is negative 6y. 2 times 12 is going to be 24. Okay, equation B here, I'm just going to copy down. Negative 4x plus 6y equals negative 24. I can go ahead and add these up. Now what happens when I add these up, my x's go away. I get 4x minus 4x is 0x. Negative 6y plus 6y is going to be 0y. So 0x and 0y, we really have 0 on this left side. On my right side, I got 24 plus a negative 24 is going to be 0. So this is what I was talking about when I was saying that either your x's and y's both cancel, you're either going to have no solution or many solutions. In this case, 0 does equal 0, so it's going to end up being many solutions. Okay, if you had gone ahead and solved for y on both of these, what would have happened? Okay, I just want to talk about a different way to do this. So if I had solved this top equation for y, I would subtract 2x. So I get negative 3y equals negative 2x plus 12. I could have then divided by negative 3, leaving me with y equals negative 2 divided by negative 3 is going to be a positive, okay, 2 over 3, x. And then 12 divided by negative 3 is going to be negative 4. Okay, if I looked at equation B over here and solve for y, I would add 4x. So I have 6y equals positive 4x minus 24. I would then divide by 6. 4 over 6, when you think about it, is going to be the same thing as 2 over 3, right? They're both even numbers, so you could cut them both in half. Half of 4 is 2, half of 6 is 3, so we get 2 thirds. X. 24 divided by 6 is going to be a negative 4. What I see here is that these are the same line, and we know that if we have two lines that are the same, they're going to intersect at every point on that line, which is why we end up with many solutions there. Okay, this next one. If you guys remember, this, or I should say, having x equals a number is going to be a vertical line, and having y equals a number is going to be a horizontal line. So if we have a vertical line at 3, a horizontal line at negative 5, okay, how many places do they intersect? Okay, there really is just going to be one solution then. Okay, remember a vertical line and a horizontal line will be perpendicular to each other. So they're going to cross at 90 degrees. The solution of this one, once again, is going to be my x value is 3, my y value is negative 5, which makes sense. We have x equals 3, y equals negative 5. Okay, I'm not asking you what the solution is, but that's what it would be. I'm asking you right now, how many solutions? All right, this one looks fun. So one thing you could do is solve for y on both of these. Or you can think about what the graphs are going to look like. Okay? Let's think about what these graphs are going to look like to begin with. So I know this top graph, I could graph that right now. I have a point that is going to be, remember this is like x1, y1. Negative 8 is going to be my x value, and negative 4 is going to be my y value. Remember, those are just going to be the opposites of what they look like. My slope is going to be 1/2. Now down here, what I might want to do is solve for y to get it in y equals mx plus b form. When I do that, I'm going to subtract x, so negative 2y equals negative x plus 10. Divide by negative 2, I get y equals negative x divided by negative 2 is going to be a positive 1 over 2x. 10 divided by negative 2 is going to be negative 5. Alright, so this is one way to do it. I could go negative 8, negative 4. Now I really caution you doing it this way, trying to graph it, because it's really easy to kind of miscount when you're graphing some crazy, like negative 8, negative 4. That's way out there. I go up 1 over 2. Okay, up 1 over 2. It gets really easy to get off here. Okay, I think I did that right, yeah. Alright, we'll roll with that. Okay, this line is going to be 1/2 x minus 5. So my y-intercept is going to be negative 5. And I can go up 1 over 2. Well, I do know that these do have parallel slopes. Or I should say they have the same slope. So it's either going to be no solution or many solutions. Okay? I can pretty clearly see that these are not the same line. So it's going to definitely be no solution. Okay, that's not a great way to solve that. I just want to go over a couple different options for you though. Okay, another option, you can just solve them both for y. Here I got y equals 1/2 x minus 5. I'm not going to redo that. Over here I could get it in the same form, solve for y. So when I solve for y, maybe I want to distribute the 1/2. Okay, so I'm going to end up getting y plus 4 equals 1/2 times x is 1/2 x. 1/2 times 8 is going to be, well, 4 is half of 8. At which point I would just subtract 4. Y equals 1/2 x. 4 minus 4 is 0, so I'll just leave it like that. Right here I can tell these are parallel lines and they are not the same line. So they're going to be, once again, no solution. Okay. So guys, I'm going to throw up 4 more problems for you. See if you can do them. Then we'll call it good, I think. Yeah. Alright. ABC's next one is going to be D. Number D. No, we already did that one. Alright. E, we still have 3 more though. Or 4 more. I just don't know my alphabet very good. Alright guys, go ahead, pause the video. See if you can work through these. Once again, I'm not asking you to solve, I'm asking you how many solutions there are. So your answer should be no solution, one solution, or many solutions, because these are all linear. There is not going to be any quadratic, so there's no way you could ever get 2 solutions out of this. Alright, so go ahead and see if you can do it. Alright, we're back. Okay, so for E, remember you could just solve for y every single time. Sometimes it's going to come out nice, sometimes it's not. What I might want to do here is I realize that if I could just solve for x and y, I can just add these up and my x's are going to disappear immediately. Okay, so my x's go away, my y's also go away. So I have 0 equals. Now I tried to trick you here, okay, thinking that you need to subtract everything. Okay, you're really adding the numbers. It's just 2x plus a negative 2x is 0x. 5y plus a negative 5y is 0y. 25 plus 25 is not 0, it's 50. Okay, so remember, no solutions and many solutions, your x's and y's are going to disappear. When that happens, it's going to be either a true statement or a false statement. This is a false statement. 0 does not equal 50. Okay, so that's going to be no solution. Okay, so if you go ahead and try to solve for x and y every single time, if you get an answer for x and y, that's, like I said, one solution. Okay? If your variables cancel, false statement, that's no solution. Okay, if you're solving and both of your variables cancel and you're left with a true statement like 0 equals 0, that's going to be many solutions. Okay, so just keep that in mind. Here you have y equals 2, y equals 0. Think about what these lines look like. Okay, or I should say, if you have y equals a number, isn't that a horizontal line? So we have a horizontal line at y equals 2. We have a horizontal line at y equals 0. Horizontal lines are parallel to each other. If they're parallel to each other, they're never going to intersect. Okay, so we're going to say that is no solution. All right, our next one, G here. What you could do is, give me a second here. People are knocking stuff over. Don't even apologize or nothing.
Sorry, Mr. Gurney.
Uh-huh. Bunch of clowns. All right. So one option you could do is you have y equals, you could plug that in for y and do substitution method. Okay, I really don't like substitution method. What I would rather do is just solve this equation for y and see what we get. Alright, so if I solve this for y, I get negative 3y. I subtract 6x on both sides. Like so, then I can just divide by negative 3. I get y equals negative 6 divided by negative 3 is going to be a positive. 6 over 3 is 2. Here we've got 18 divided by negative 3. Well, it's going to be a negative. 18 over 3 is 6. So you guys look at these, aren't these the same equation? Okay, the same equation is going to be many solutions. Just like so. Let's go ahead and solve that another way though. I told you that substitution method, right? So I could rewrite this equation, 6x minus 3 equals 18. Okay, I didn't write the y, I put parentheses there because y equals 2x minus 6. So I'm going to plug in 2x minus 6 here. Okay, here I could then try to solve. My first step in solving is distributing my negative 3 into the parentheses. I get 6x. Negative 3 times 2x is negative 6x. Negative 3 times negative 6 is a positive 18. And that equals 18. Here we just want to combine the like terms. Okay, so my x's go away. I'm left with 18 equals 18. So guys, my variables disappeared and I'm left with a true statement. Isn't that the same thing as many solutions? Okay, so I'm just trying to give you guys different options, really trying to understand different ways how to do the problem. Okay, I don't care how you do it, just figure it out. Get it right. Okay, the last one over here is going to be h. So we got a couple different methods again. We have y equals something. I could just take that and plug it in for y down here. Okay, another option is just solve this equation for y and see what we get. Okay, so remember, the reason I do that is because if I get the same exact equation, if I end up with y equals 2x plus 4 here, it's going to be many solutions because it's the same line. If I solve all this and I end up with y equals 2 over 3x plus a different number or minus a different number, those would be parallel lines. Okay, parallel lines never intersect, so then it would be no solution. If I get literally anything else, it's going to be one solution because it's linear. So the first thing I'm going to do is distribute my 2 over 3. So I've got y minus 6 equals 2 over 3 times x. Okay, remember if we do negative 3 times 2 over 3, how do you multiply two fractions? Well, 3 is just negative 3 over 1 really. So you can multiply straight across when we multiply fractions, or you can look to reduce up and down as well as diagonally. Okay, so here my 3 and 3 would reduce to a 1 and a 1. So I have negative 1 times 2 over 1 times 1, which is 1. Okay, another way to do it is, like I said, you could have multiplied straight across. Okay, if we had multiplied straight across, I would have gotten negative 3 times 2 is negative 6. 1 times 3 is 3. Negative 6 over 3 is really going to reduce to 2. Negative 2. Alright, so this is going to be a minus 2. My last step here is just to add 6 over. So I get y equals 2 over 3x. Negative 2 plus 6 is 4. These are, once again, the same equation, so it's going to end up being many solutions. Okay. Hopefully that didn't confuse you and you can now do all of your homework.